I never set out to win a Nobel Prize. I only set out to do everything to the best of my ability, and I never put in a second-rate effort. With such resilience in his work, Sir Harold Kroto finally became the co-winner of the 1996 Nobel Prize for Chemistry. This professor from Florida State University was awarded the Nobel Prize for his discovery of the carbon compounds called fullerenes. This discovery opened up an entirely new branch of chemistry with consequences in such diverse areas as astrochemistry, superconductivity, and materials chemistry, physics. Professor Sir Harold Kroto presently carries out research in nanoscience and nanotechnology and has served as president of the Royal Society of Chemistry. He has also set up the Vega Science Trust, a UK educational charity and TV science channel accessed by over 165 countries, of which many programs have been broadcast on BBC, aiming to improve knowledge and raise awareness of scientific achievements.
Hello and welcome to this special edition of Talk Vietnam for an exclusive interview with 1996 Nobel Laureate in Chemistry, Professor Sir Harold Kroto from Florida State University. It's our great honor and privilege to have him here with us. Today, we'll learn more about the discovery that won him the Nobel Prize and his unique philosophy of science. Professor Sir Harold Kroto, nice to meet you. Hi. Thank you so much for being here with us.
Did I have a choice?
Well, how are you today?
Well, I'm still alive, more or less, but interesting, and my first visit to Vietnam, and so far it's been very interesting and enjoyable.
That's great. What was your first impression upon arrival?
Well, I haven't had a lot, but I mean, one first impression is that there's quite a lot of building going on, and also that a lot of the houses that I saw were well constructed, and they, in a way that many buildings in the USA, they're made of wood and will fall down in a hurricane. But I've not been really here long enough to form an impression. I only know of Vietnam from outside and from films and things of this nature. But I have a good impression of Vietnam, partly because I see something deep in the culture that has allowed it to make friends with America after the difficulties of about 50 years ago. And I think Vietnam has is a lesson to other countries in the world on how they can overcome those sorts of difficulties. And so I've always felt there's something special about the country that can do that.
And what made you decide to donate your valuable time and energy to the 4th ASEAN event series, Bridges Dialogues Towards a Culture of Peace?
Well, I think I've been I'm invited somewhere every day, and that was one that interested me, but it took a long time to come and to be able to come, because I have a long backlog of requests. But I mean, peace is obviously something that interests me. My view is that I'm going around the world and talking to young people and trying to inspire them to do science and think about thinking for themselves, but also developing a humanitarian attitude, and hopefully, if they get into positions of responsibility, change the direction of politicians towards working together to solve their problems, rather than sending young people to go and kill each other.
Yeah. And how about your schoolboy times? You were still a schoolboy when you developed what you call an unhealthy interest in chemistry.
Yeah, that's a bit of a joke, but yes, yeah. But when I was young, I was good at making things with my hands. And my father, who was a refugee, really ensured that I had things to make.
And you mentioned your father, so did your parents have a great influence on facilitating your interest in natural science?
Well, my father was an engineer, and he did influence me, because he gave me an electric train set, and I had Meccano and things. He certainly, these were things that were given to me. And I also had a big room it was an old house. It was really in the slums, but I had my own world in there, where I had a train set and made things out of a set called Meccano and things of this nature. So he definitely encouraged the practical side of things, and less so on the art side, because that, but I think, I even today think I'm better at that, although I've had much less practice at it than I really would have liked to have done more of that than I've been able to do.
Were you the best in your class as
no,
a student?
not at all. I was good, but I was never the best in the class, and it depends what subject. So I was up in the top quarter or third in general. The only thing I was best at as a young child was geography. I mean, that was the subject, and I remember coming top in geography and deciding, oh, I can be top in something, so I'll focus on geography, and I think that's part of it. But I don't like competition. I don't think it's healthy. I think the thing top of the form is not a good thing, because there are kids at the bottom. We've got to have a totally different attitude to schoolwork. We somehow have to encourage people, the young kid who's bottom of the form. What sort of incentive is that? So there's something really at a very fundamental level not right in the way that we imprint competition as being good in our schools and education programs. I don't know what the solution is, but that's definitely not one of them. Because every kid has some potential, and I think a lot of them, when they're bottom of the form, then feel that's it, and they can't achieve anything. And we need to rethink that.
Definitely. And what advice would you give to a child who would want to be where you are now? Well,
don't even think about it. I mean, I've said that I'm a Nobel Prize winner, and I never thought of this. And if people had said you're going to be a Nobel Prize winner, I would have said you're crazy. I didn't go into science to win any prizes. I didn't even go into it to be a professor. The advice I have to all children, whatever it is, it's not about science, is to find something which satisfies them. So, I don't like the word enjoyment. You say, I enjoy this. I don't enjoy hard work any more than anybody else does. On the other hand, I think people who are successful in being creative get something else. They enjoy when they're finished, but they're able to somehow just immerse themselves in a creative process where hard work doesn't seem hard work. It's something that the hard work pays off by achieving something at the end, and they're satisfied that they've done something that nobody else could do. But it's also something that is determination. And I tell young people, if you're doing something and a second-rate job satisfies you, find something else where only a first-rate effort, your best shot, will satisfy you, and then you'll be successful.
Sir Harry Kroto was awarded the Nobel Prize in Chemistry in 1996 with Robert Curl and Richard Smalley for the discovery of C60, the molecule made up of 60 carbon atoms that garnered fame for being shaped like a soccer ball. C60 was named Buckminster Fullerene, or buckyballs, in tribute to the architect Buckminster Fuller and his iconic geodesic domes. The discovery of buckyballs led to an entirely new branch of chemistry, the science of fullerenes. Until then, carbon was only known to take on two forms. One was extremely hard, diamond, and the other very soft but electrically conductive, graphite. The new fullerene molecules and their close relations, carbon nanotubes, often exhibit both of these properties and are already being tested in solar cells, nanocircuits, and drug delivery systems. Carbon nanotubes have already proven to be the strongest materials in the world and promise exceptionally light and versatile components.
I have a mission to ensure that people understand science. Science is about asking questions and curiosity.
So how about your Nobel Prize? What triggered your discovery of C60 in 1985?
Well, I was interested in the chemistry in a star, but I've done 20 years of research to get to that, and we'd done some work in the laboratory with a colleague, David Walton, which ended up at a nice piece of research, which ended up with the discovery of molecules in interstellar space by radio astronomy. And then other people discovered an interesting star which had some interesting chemistry. And I was interested in that. And just by really pure chance, I was visiting Rice University with a friend of mine, a scientist, Bob Curl, who said I should go and visit Rick Smalley in another lab. He's doing something interesting. And it looked interesting. And then I went to see him. And during this that visit for an hour, I could see that this technology that Rick had created really was revolutionary as far as cluster science was concerned. Might actually just solve a little problem that had been in the back of my mind. Not very important, interesting to me, not really interesting to anybody else. And then we did it, and it worked exactly as I expected, except that it had an incredible surprise, that it did something else. The result was, I mean, I didn't even need to do it. It seemed to me it was obvious it was going to give this result, but it did something else totally unexpected, and that led to the Nobel Prize. And there's a lesson here that here was an experiment that wasn't particularly important to my colleagues. It was more important to me personally, but not on a outside level. Just wanted to solve a little problem in my head, and here was an incredible breakthrough which was totally unexpected, and that's the way that many breakthroughs are made. It's not going after these important things. It's not competing with other people. If you're competing with other people, 100 other groups who think this is important, then you've only got a 1% chance of making the breakthrough. So do what you're interested in doing. Don't worry about others. Of course, you've got to convince people to give you the money to do it. Well, work hard on that, and then piggyback your real interest on top of this thing. And
you also once said that science is misunderstood in many ways.
Yeah.
Can you elaborate on that, please?
Well, the first that young people, and the iconic image of a scientist is really Einstein as an old guy with long hair, when in fact he was, he was a young man with very short hair when he made the big breakthroughs. So that's the first misunderstanding of who the scientists are. The second part is much more serious one, and that is that science is not understood by anyone, particularly people who are journalists. And that is the only 9 out of 10 times when a journalist comes to ask me about it, they ask, what are the applications of your discovery? Now, that's because the only thing understood is not the science itself or what the discovery was, but how it can apply to society. But that's not the way that much science works. The third thing, arguably more important, is how does a scientist discover something that's unknown beforehand, the scientific method, and how is that done? And that's the scientist. But I think there's something much more important than that, at a very deep intellectual, cultural, and educational level, and that is to recognize that science is really quite new. It really only goes back about 500 years. Before that, it was common sense, and common sense is what you need to survive. But before it was called science, it was called natural philosophy. And the point that I make is natural philosophy is the only construct we have to determine what is true with any degree of reliability. And I think we should teach that to young people in school. And we should teach them to question and ask people, ask their teachers, just a minute, you're telling me this. How do you know it's true? What is the evidence for what you're telling me? And if they can't find evidence, then it's not necessarily true.
Upon his arrival in Hanoi, Professor Kroto has joined a press briefing at Hilton Hanoi Opera. Let's take a look.
As part of the 4th ASEAN Bridges Dialogues Towards a Culture of Peace series, Nobel laureate Professor Harold Kroto was invited to be a speaker during his stay in Hanoi. Known for one of the most important contributions to the development of nanoscience, Professor Kroto hoped to have some impact on Vietnam's education sector.
We have invited Professor Kroto because he's speaking about education as a basis for peace, which is the main theme of the International Peace Foundation. Because we are supporting universities with connecting them with Nobel laureates. We are supporting education and schools because we think that this is the real basis for peace in the future.
Professor Kroto isn't only focused on science. He also has made a lot of efforts to help boost education and science around the world. Answering questions from Vietnamese journalists during the visit, he emphasized the importance of education, saying that it is good for the development of Vietnam in the future.
Your educational system must cater across the spectrum, from those who have, in the sciences are good at solving clear, important problems, to others who are good at solving their own problems that no one else has thought of, and then where surprising breakthroughs are made, which will be useful for Vietnam.
During this visit, Professor Kroto met Deputy Prime Minister Nguyễn Thiện Nhân and students at the Vietnam National University, Hanoi. This is the first visit of a Nobel laureate in chemistry to Vietnam.
So, how has the Nobel Prize changed your life?
Well, the first thing is that I gave a lot of lectures before, but now I give a lot more lectures, and it's an interesting question. So it has meant that I'm on the road. My wife is on the road. We're both on the road, probably 1/3 of the year.
Oh, wow.
And we were in 127 hotel rooms,
Wow.
127 days in a hotel last year. And I feel a responsibility particularly to talk to students wherever I go.
Looking back at your career path so far, have you ever felt that it was tough to get through? What was the biggest challenge that you had to overcome?
Oh, it was very hard. And I mean, personally it was very hard, but got a lot of support family-wise. Really a burden of taking off, and I think probably not very good because I worked too much, and certainly at the start, over much, and I think to some extent, you know, that took the toll on the family a lot more. But I think science is not easy, and it was 100%. I mean, not later on, but certainly at the start, to get research going. I didn't know how. I think if I'd known how hard it was, I would have done something else. I've often said it's like going in the ring with Muhammad Ali. And on Monday, Tuesday, Wednesday, Thursday, you get knocked out in the first round, you pick yourself up on Friday, maybe you get to the second round. Once a month, you get to the third or fourth round. Once a year, you get to the 10th round. And if you're incredibly lucky and he sort of has an off day, you might sneak around and knock him on the nose, and, and you get the Nobel Prize. And that's hard to take, and you have to have a certain internal resilience, which most scientists actually have, and not everybody has. And not everybody has the supportive family around them that I had.
You made a summer 2012 presentation at the 62nd Lindau Nobel Laureate meeting in Germany. And this annual meeting brings together Nobel laureates and young researchers for integrational inspiration.
Yes.
A key line in your Lindau presentation was, "I'm not here to make you feel comfortable, I'm here to make you think."
Yes.
And so can you tell me a little bit about that experience in Lindau?
Well, I mean, I've been to Lindau many times, and as time has gone on, I underneath that has always been to get people to think, because I think it's very important that they don't accept what other people tell them. I also said, this is a quotation which I like very much: if you make people think they're thinking, they love you. But if you really make them think, they hate you. And this is by a journalist, Don Marquis, in the 1930s. I think that the young people who go to Lindau, many of them will be going to positions of responsibility, and they will become leaders. And for me, leadership is about leading young people to think for themselves, so that they no longer need to be led.
So we know you're committed to global science education and the development of internet streaming technologies.
Yes.
Can you tell me a little bit about your success in the field?
Well, I'm not sure it's successful. I think it's successful, but I started off over 15 years ago making programs for television, BBC television, because they had an open access slot. And in those days, the technology was very expensive, and it was quite expensive, and I had to pull in a lot of money to do this. And over 15, 16 years, I think we were very successful. But also, the internet became very powerful, and I recognized one of the greatest breakthroughs in education was Wikipedia. However, it seems to me it's objective. What we're trying to do is going to the next step from Wikipedia, and subjectivity. I want to see the person who created a particular idea. I like to see young people trying to teach. And they don't even need to have a lot of experience. I just want to see their enthusiasm for that. We're distributing an idea so that schools, universities, individual teachers can contribute this, recording themselves, explaining particular concepts that they've developed. Everybody sees something in a different way. We're looking at the same object, the same idea, the same